Hello and welcome back to the good stuff we've been doing. In the previous video, we discussed about long rule for multiplication, and we arrived that we could actually multiply this expression by this one using this method described above. So if you haven't watched with, so if you haven't watched uh, that part, I suggest you do, because it's essential in understanding what you're going to do next. But what I have to say is that we don't really have to write down this number, this x cubed, this x square, and this x, or this x square and this x here. We don't really have to. So we have to multiply x cubed, s 2x squared plus 2x plus 1 by this term here. But then if you notice that since we know that the power of x here are decreasing, you have x cubed, x squared, 1 and 0 here. We don't really have to represent the powers here because they did not even change anything much. Last what we had was that the highest power was x to the fifth power, second highest was x to the fourth, x cube, x squared. So if maybe you have something like 1 here, 1 here, we know that this one corresponds to x to the fifth power, this one corresponds to x to the fourth, this one corresponds to x to the third power, and so on. So what we can do, this method is called the method of detached coefficient. So called the method of detached because here we're going to detach the coefficient. I hope I spell this well. I think there is h here also. I'm not the best speller in the world, but this is called the method of the detached coefficient, and this is how it's done. We first of all write down the values here, like instead of writing x cubed 2x squared, we just write 1. The coefficient of x cubed is 1, we write 1. What about the coefficient of 2x squared? Is just 2. So now we don't write the coefficient. So we're detaching the coefficient away. Right? So what about the coefficient of 2x? See, just 2. Coefficient of 1, just 1. What about here is 1, negative 1, and 1. So this is what we should obtain. Now when we do the multiplication out, we get here 1 times 1 1, 1 times 2 2, 1 times 2 2, and then 1 times 1 1. Here we have a negative 1 times 1, negative 1, negative 2, negative 2, and negative 1. Then here we have a 1 times 1. So 1 times 1, we have a 1. 1 times 2, we have a 2. And then 1 times 2, we have a 2. And then we have a 1 times 1. Of course, yeah, so we have a 1 here. So when we rule the line, we bring down this 1. Here we have 2 minus 1, which is 1. Here we have this cancels out, so this is 1. So this cancels out, this is 1. And then this is 1, and then this is 1. So when we arrange it, this part will correspond to x to the power of 0, x to the power of 1, x to the power of 2. This corresponds to x to the power of 3. So x to the fourth power, and then x to the fifth power. So after the arrangement has been done, you see that this product should be equal to x to the fifth power plus x to the fourth power plus x to the third power plus x to the second power plus x plus 1, because x to the 0 power is 1, which is actually the same thing we got. So looking at these two methods, let me shrink the board. Okay, now look at these two methods here. For this part, let me demarcate it. Okay, for this part, for this part here, we notice that we involve the x cubed here and the x squared and the rest, but this part we did not. But we did not lose the final answer. So that means there's no point in asking now the x's. We can just detach the coefficient. That's why this method is called the method of detached coefficient. So detaching the coefficient out, leaving the powers. So long as the terms are in x cubed, x squared, x to the first power, we are all safe for this method here. So because of the fact that this one is x squared, x to the first power, x to the 0 power, so we can write it this way and then proceed as this. And when we get the final answer, we know that this power will be x to the fifth. If we had gotten 7 here, let's say we got a 7 here, this part will be 7x to the fifth power. That's how it works. If we get here 2, this will be 2x cubed. So that is how the stuff is being done. Now you may ask me, what if I get to multiply things like x to the fifth power minus x to the third power plus say x square, where the powers are not uniform? Let's say this, there's a gap here, there's no x to the fourth, here there's no x to the 1 power even, there's no even constant term. We're going to answer that question in the future videos, or maybe check the method of the detached coefficients, maybe part 3. Part 2 is going to reserve for working on the example. Still, this the second example I worked that involved p r s square. Those who follow the video know what I mean. That's part we're going to do with detached coefficients. Then the other video will be for this part where we're going to discuss in general situation. So thank you for watching, and please subscribe to the channel. Have a nice day.